Let me create a new project. And are we on what, day 5 today? Day 4? What is it?
Day 6.
Day 6.
Day 6. Day 6 today.
Yes, sir. Day 6.
Yes, sir.
Okay, time has gone by very quickly. All right. So just to take you back to what we talked about, quick recap of this. We said that there is an iCollection interface, and then the iList inherits from iCollection. One example of the iList which we saw yesterday was the ArrayList class. The other collection, other interface that inherits from iCollection is iDictionary, and the iDictionary would always have 2 items in there. One would be a key and one would be a value. So we're going to start off our discussion today with looking at iDictionary. 2 options that we have in the iDictionary, the hash table and the sorted list. So let's start off with the hash table. Yeah, what's missing? I don't get the hash table shown out here. The reason is because why? What's missing?
So we have not imported the collection using
So
collection.
you need to give a using on that. And do you all remember what I gave you all for how I don't remember whether I've shown you this or not. I think I have. How you can add a using? You can just come in here and
No potential fixes.
yeah, show the potential fixes. Actually, this is not the correct way of giving hash table. It's actually a single small t. And in the potential fixes, one of the options shown out there is a using statement. So hash table, whatever, let's say O is equal to new hash table. Every collection, when I say the word collection, what are the 3 things that you must immediately associate with the collection?
Add, remove, count.
Add, remove, and count. So let's try with the add first. O.add. And if you can see out here, you got 2 things to be added: object key and object value. So your key can be an object and your value can be an object. The key must be a unique value. You can't have duplicate keys in your dictionary out here. And the value, whatever is the value here, in this case I'm giving the value as a string. Okay. Now if I try adding a duplicate key, immediately it gives me an error. So for example, if let's say if I tried adding a element with a duplicate key, that would cause a problem immediately. And let's try running this. So line number 19 throws up an exception saying that the key is already there and you cannot add a duplicate key, right? All right. Now there's an alternate way, alternate syntax that is generally used out here. So see what I'm doing out here. I'm saying O of key equal to value, right? Now when you do this syntax, 1 or 2 possibilities exist. Either the key already exists, and if it already exists, then what will this do in this case? In this example, how would it work if it is already existing? Any guesses?
Yes. So it will update.
It will overwrite that value. The earlier value that you had would be overwritten with this value out here. The second possibility is if the key does not exist. So for example, if I did this O of 4 equal to, let's say, a new value out here, let's say this. So if the key does not exist, then it will actually create a value. Okay. So this one given exception, it will simply for an existing key override the value. So rather than use this syntax, rather than use an o.add syntax, generally in most code that you write, you'd be using this sort of syntax. And the reason being that it won't throw you an exception if the key is already present. It will then just simply go and override the key. And that's what you might want to do in most situations. Let's try printing these values. If I wanted to iterate through it using the for each loop, the collection here in this case is the variable O, right? Now, what is this a collection of? If I don't have the code for my hash table in this project, sorry, the code for array list in this project, but in the array list, if you remember, when you wrote a for each loop, you are iterating through it using an object. You're saying object item in the array list object. But here, this is no longer going to be an object. This is no longer going to be an object. Instead, you have something called as dictionary entry. So there is a struct called dictionary entry. All right. Now, when we added it, what are the two things that we added out here?
Key and value.
And value. So every dictionary entry has two properties. And the two properties are, in this case, item is your dictionary entry. What will be the two properties that this would have? One would be a key and the second one would be a value. Are we clear on this, everybody? So this is what we can do to display the key and the value. Okay, you can format it better and just writing this down this way. All right. Let's try running this. Okay. Now you'll notice that the order is not maintained. It's brought in as 4, 3, 2, 1. I've added it as 1, 2, 3, 4, but it's storing it as 4, 3, 2, 1. Now you may not necessarily get the same order every time in a hash table. So when you're storing the values, it's not in a sorted manner. Now in quite a few situations, you may want this to be a sorted, dictionary. So rather than using the hash table, in this case, you could use the sorted list. Sorted list would have similar properties like the hash table, but the additional feature that you would have out here is that elements should be sorted on the basis of the keys. So all that I'm doing here is, instead of a hash table, picking up a sorted list. Right. And if I try the same output now, you can be sure that the values will be shown in a sorted order of their keys. Whatever the keys that you have will be sorted on the basis of the keys. All right. So that's how you iterate through a dictionary. Let's try out a few other methods out here. Now you have remove and remove at. So you use these before. Remove requires you to pass the key, whatever the key out here. So supposing I said remove 1, right? What would this try to do in this case? Which one?
Key 1.
Key 1. So which initially was Vikram, but then has been replaced. The value has been replaced with new. That's what this will do. On the other hand, if you use remove at, this does not refer to the key, but instead refers to the index. So if these are the 4 values that you had, remove at would remove what?
Harsh.
The second item in the list, because it starts from 0. Index 0 and then 1 is the second item in the list. So be aware of both of these, remove and remove at. In one case, you're using the first case. Here you're using the key to remove it. and here you're using the index to remove it. Okay. Let's look at the other methods that we have out here. So we've tried out add. You'll find that there are certain methods shown there with a down arrow. Okay. Now these methods are what are known as extension methods. And we'll be looking at extension methods a little later in our session, not today, probably on maybe Monday or Tuesday, we'll be looking at extension methods. These extension methods that you will see out here for collections are mainly for working with link. So we're going to again see another concept here after we see extension methods, something called as language integrated query or link. And that's where these methods would be used. So at this point, do not use them. Any method that you see with the down arrow there, ignore for now. We will be using them, but we'll be using them after we have understood and tried out a few more concepts. All right. Okay, let's go through some of these. Capacity. Do we remember capacity? Could someone tell me what capacity does and where you use capacity?
To find the size.
So to find all the record in a database.
One second, let me correct that. To know how many elements are there in the list. If that's what somebody said, to find the size. What is that property?
Count.
Count. So please don't mess around with capacity and count. These are two entirely different concepts. If you wanted to know how many items are there in the collection, you're going to use the count. I told you right at the beginning, add, remove, and count. Moment I say collection, 3 light bulbs, ting, 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 in your head. Add, remove, count, add, remove, count. Okay, so don't mess up with this. Going back to capacity, yes, somebody else would like to answer that. Where do you use capacity?
So when we are trying to fetch data from database.
Basically, where you are adding items into a collection in a loop. Anywhere where you're adding items in the collection in a loop, instead of increasing the size or increasing the amount of values that it can have, instead of increasing the memory by one unit, you can give a block of memory by changing the capacity. And when you change the capacity, it allocates it by that block rather than one by one. So it runs, your code runs faster and make sure that you're not having to allocate memory one item at a time. It allocates memory a block of items at a time as specified by the capacity. All right, I gave you an example of where you could use that. I have written pseudocode for it, where I've used capacity, and at the end of it, I've actually used trim to size. So that was the example that we did with array list. But that same example is true for all collections that you're working with, not just with array list. So a lot of these things will be common. Now, I don't know whether you all are just, today being, I started the session a little early, so you're just still lazing around in a little relaxed mood. I don't know about that, which is why not many people answered this. But I expect you all to jump on me with answers for concepts that we have covered earlier. All right. Okay, so I'm not going to cover the same things all over again. Things that are common, I will just talk about them without necessarily covering them. So capacity we have tried. Clear, what does clear do?
Delete all the values.
All the entries.
So it will, in case of a collection, it's like a remove all, deleting all elements from a collection. Clone, I asked you all to read up on that. I am not covering that right now. Okay. Contains, the next one. Now contains here is just going to give you a Boolean value telling you whether the item that you're trying to search for is there in the list or not. So for example, if I said contains, right? And let's say if I said O dot contains and the key that I'm looking out for, let's say whether I'm looking out for free. Now in this case, that key 3 is present. In this case, key 3 was Ananya. The value was Ananya. This would return a true. But for example, if I gave a key which is not present, so in this case, this would return a false. So contains is simply giving a true or false value. Now, one of the methods comes in from the base I collection, and the other one comes in from the sorted list. So there are actually two methods out here. There is a contains and there is a contains key. Both of them work identically. There's no difference between this and this, right? One of them is coming from the interface, one of them is coming from the class. The class additionally defines one more method, but both work the same way. So both contains and contains key work exactly the same. Right? There's one more option here called O dot contains value. As the name suggests, contains value. What will this check out for now? Instead of the key, what will it check out for?
Value.
The value. So the syntax or the usage is similar to contains, but here this is checking for contains a value or not. Okay. All right. Copy 2. We have used that in array list. What does copy 2 do? Yes, copy 2. What will that do?
Copy one collection into other. And one array to other.
One list.
Sorry, one sorted list to other sorted list.
Array, sorted list to array.
Sorted list to
Copies from a collection into an array.
array.
All right, into an array. I appreciate you're trying to give answers, and I like that fact that you're going and giving answers. But I have told you this yesterday that collections are one of the most important topics in .NET. Everything that you do in .NET will involve some form of collections or the other. Right? These collections, it's not that today we have finished. By the way, Monday there's an exam. I think you'll know about that. Monday you finish the exam and end of the story, remove it from the memory. Collections are going to stay with you throughout .NET. Even later, much later, last day of our training also will be using some form of collection or the other. So this is one topic that I want you to master. I mean, I wanted to master all topics, but this is one topic that you'll be using throughout. So make sure that you're not making, any mistakes on collections. You should know all these methods. All right, count we have talked about, right? Now, what are the three things that you have in this sorted list? We are using a sorted list right now. So dictionary-based collection. What are the three things you will have? You will have one is the key, one is the value, and third is the index. These are the three things that you would be working with. So there'll be a lot of methods wherein they are telling you, you give me one, I will give you the other. Right? You give me one and I'll give you the other. See, for example, this one, get by index. All right. So this returns the value for a given index. So what am I giving it? What am I supplying? I'm specifying the index. What is it returning?
Object.
The value. The object here is okay, but what exactly is it returning from there? It's returning the value that is there at that given index. So like this, there'll be a lot of methods. You give me the index, I'll give you the key. Give me the index, I'll give you the value. Give me the key, I'll give you the index. Give me the key, I'll give you the value. So a lot of these methods would exist, right? So let's try this one first. So get by index. So here in this case, let's say I said index 0, right? And if I did console.writeLine, for example, this returns, gets the value out. Okay. I'm going to comment out this code so you can actually, try it out in the lab on your own. All right. Okay. Look at the next one, get key. What is this get key doing? Look at the syntax and tell me, what am I doing?
So passing the index and getting the key.
Pass the index and get the key. So look out, it gives you a one-line explanation of what it's doing. So in case you don't remember it, while trying it out, read that line out there below it. Okay. The next one, get key list. What is get key list doing? As the name says, get key list.
Provide all the keys present.
Correct. So it gives you a list of all the keys. It returns an I list. On the left hand side is returning an I list. So see what I'm doing here. I list, whatever, let's say O list, for example, is equal to O dot get key list. Now, when you do this, remember I list here. I list is the base interface for array list. So this will give you all the methods that you have tried with array lists. These would be available through iList. So you can do olist dot and see all the things that you want. If you want to iterate through it or whatever the case might be. So you can actually do that out. Okay. Similarly, just like there would be a get key list. What are the other one that should be there? Just like key list. There should be one more, which is what?
Get value list.
Get value list. Right. So you can get a value list, get a key list, whatever you would like to get out. Okay. All right. Next one, index of key. I don't even need to tell you this. I mean, just by reading the name, you should know this. Index of key. What am I passing to it? I'm giving it the index. Sorry, I'm giving it the key and it is returning the index. All right. Okay. Next one, index of value. So I'm passing it a value and it's giving me a index of that value. But the values here could be duplicate. There could be, values that are repeated values. So what it does is finds out the first value that matches that and returns the index of that value. Keys, of course, will be unique. So key will not give you duplicate values, but index of value could give you duplicate values. All right. All right. Ignore the is fixed size, is read only, is synchronized. Ignore this. The next one, keys. Keys. Whenever you see a plural ending in S, right? That's a collection. Any in .NET, if you see any property ending in the letter S, that's a plural, right? So any plural is typically a collection out. So keys, right? Keys is what? What would this be? One. What is
collection
this?
of keys.
A collection of all the keys. What is this returning? Returning a I collection. So you can get all the keys out here and then try to, maybe work on the keys, loop through the keys or whatever you'd like to do out here. Just like keys, there will also be what? If there is keys, there should also be what?
Values.
Values. Somewhere later, there would be a values. Keys and values, right? Gives you a collection of all the keys in here or all the values in here. What is this similar to? What is this similar to?
So get key list.
Get key list, get value list.
Or get value list.
So why does it?
Why does it? I think Kaustubh got
Stuff.
So
frozen.
when we have get key list, why we are moving keys only?
See, what happens is some of the methods are coming in from the base interface. Some of them are coming from the defined in the base interface. And some of them have been again defined in the class that implements that interface. So that's why you find that there are two implementations of this, and you can use either of them. Okay.
Sir, can you
Yes.
repeat it? I missed it because there was a power cut off.
Okay. I'm saying that I think your question was, why are there two of them? Is that
Yeah,
what
I
the
mean,
question
like
was?
one is returning iList and one is returning iCollection. Why is it so?
So one of the methods has been written in the base iCollection, and one of the methods has been written in the either in the interface or in the class that implements that interface.
Got it, sir.
Either in the derived one or that. So which is why you might find duplicates. Like even earlier we saw there's a contains and a contains key. So a lot of these methods are sometimes duplicated. You had a copy to, which copied to an array, and then you had a to array also. So the duplication is because even though the base class thing is there, they have gone and written another method in a derived, either in a derived interface or a derived class. So they have given you multiple ways of doing the same thing. All right, so we're trying out keys. Remove at we have seen. Set by index. Any guesses what that would do? Set by index.
Inserting that specific index.
Correct. So changing the value based on the index. So set by index, you're giving the index and you're giving the value. So set by index, let's say I'm saying index 0 and value, let's say this. So this again, a lot of these, as I said, are just playing around with these three different things: key, value, and index. Okay, I think we've been through all of them. We've seen trim to size earlier. We have seen values. All right. We have talked about this. What does this allow you to do? What does this allow you to do? How can you access it? This line here on top. What is this doing? O of key equal to value. What is this doing? This is actually using the this. This is actually using the this out. So these are the some of the methods that you see with a dictionary, right? And the example that we had taken was a sorted list. Let's move on to trying out the stack in the queue, right? So these are classes that implement iCollection. So let's start with the stack. What are the methods that you generally have with the stack?
Push,
Push,
peak,
Pop, and peak.
peak.
So you could push some values into it. You could pop a value. Right? Or you could even peek at a value without popping it. A difference between pop and peek. What is the difference between pop and peek?
Pop will remove that element and peak will only return the value at that element.
Correct. Peek does not remove the element from the stack. Pop actually not just returns it, but also removes it. Right? So I think you all have probably created stacks and queues of your own, right? So you all know these concepts well. I'm just showing you how to use it out here. Q is equal to new queue. Queue karte hain. Right? And then methods that you would have here would be what? Yes?
NQ, DQ.
NQ, DQ. So again, NQ, and then this would also have a peak. What does this peak do? Same thing as what we talked about earlier. And of course, the other method was DQ. So the stack that I wrote yesterday, right, created a generic stack. I don't need to really create it. I had created that generic stack yesterday just to illustrate how generics works. How to create your own class which uses generics. So that's why I had taken that example yesterday. But there are inbuilt collection classes which do the same thing for you. Right. All right. So all of these were the non-generic collections. Now somebody asked me this question yesterday also, and I think right at the end you asked me this. If you did an array list, for example, supposing there was an array list, A is equal to new array list, and if you did an A dot add, and let's say you added a 10 out here, right? In this example, what happens here is an example of storing a value type where a reference type is expected. A dot add is expecting a reference type, but you're passing it a value type. So internally, what is happening here is boxing. Somewhere later, if you're trying to read the value from there, and you're doing the reverse process, whatever was there in the in the array list, if you're trying to read the value, so again it is being stored as the object, but you're trying to read it and maybe convert it to an integer, for example. At that point, unboxing would occur, right? What is boxing and unboxing? Have we talked about it? I don't remember whether we have talked about it or not. I really don't.
No, sir.
No, sir. No, sir.
No, sir.
No. Okay, so I think when that example of reference and value types, it was one topic that I wanted to talk about, but somehow we sort of skipped that topic. So if you did something like this, let me start from the beginning. If you had some data that you stored into this, let's say int I equal to 100. If you did O1 is equal to 100. Now at this point of time, what is happening? What is 100? What is the data type of 100, which is an integer?
Integer.
This is actually a value type. Now this value type is being stored as a reference type. So internally, what is it doing? It's taking something which is on the stack and now putting it on the heap and making O1 point to this value. So this is what is happening in memory, right? With my famous drawing skills, I will illustrate this. So that's your heap, and that's your stack. Int I equal to 100. Where is this getting stored? On the stack. So you're taking a value which is storing a int. When you do O1 equal to not 100, let's say O1 equal to I, just for easier understanding. This value of I is now going to be stored into the heap because O1 is now pointing to it. So what it does is at this point it creates another value, makes puts in a I in here, I is equal to 100, and on the heap it would now create what? O1, which points to that value. Or in other words, what will it be doing internally? What will O1 store? O1 will store what?
Binary representation.
The memory location of this. Right? We saw this the other day when we were doing reference and value types. Now this process of taking something from the stack and putting it, it's like putting it into a box and you're having a pointer to that box. This operation is called as boxing, and boxing is an expensive operation in terms of resources that you have. Taking something from the stack, putting it into the heap is going to cause you more execution time. Reading something from the heap will also cause you more time. And boxing should be, as far as possible in your code, should be avoided. Okay. Okay. Later, if I did this int j, and j is equal to, let's say, integer value of 4. Now here in the first case, this is where boxing occurred. In this line number 18, what am I doing out here in this case? What am I doing here? Creating a variable j and reading the value from here, reading the value from what O1 is pointing to and storing it into j. So j is now storing the value of I. This is what code is happening. So it's reading the value from here and putting it here. And this is an example of unboxing. All right, this is an example of unboxing. So how do you define boxing? Storing a value type, all right, or converting a value type into a reference type is an example of boxing. In boxing, what do? Take the value type and now you create another block of memory on the heap and store it in there. Unboxing would be the reverse. If you have a boxed value type, firstly, the value type must already have been boxed. So whatever has been boxed only can be unboxed. So if you have a boxed value type and if you try to read the value from there and store it back into another value type, it involves reading from the heap and creating another object variable on the stack. This process is referred to as unboxing. Okay. So why are we talking about it? Why are they being given names and why are we talking about it? It is recommended that as far as possible in your code, you should avoid boxing and unboxing because this, is an overhead in terms of doing what you want to do. So try to avoid that as far as possible. But in certain cases, it's unavoidable. Like here, what are we doing? A.add 10. What does this take as a parameter? It takes an object as a parameter. So it's actually expecting an object, but we are passing it an integer. So internally, what is it doing? It's converting this integer into an object by doing boxing. And what are they recommending? What is .NET recommending as far as possible? Yes.
Object.
Avoid boxing. Right? Okay. So rather than using these collections, we are going to use the generic collections. So these are the generic collections. So when you create a generic collection, you're creating a collection of a particular data type. Like for example, if you are creating an array list, accepted objects. But the generic version of the array list, you could say, I want an array list of integers. And it'll create an array list of integers. So while storing values, it will not accept it as an object, it will accept it as an integer. And the advantage is, first thing is, your code now can work with specific data types. That's the first major advantage. Secondly, from a performance point of view also, a generic collection will work faster and will work better than a non-generic collection. Because boxing and unboxing is not happening in a generic collection. Whereas boxing and unboxing happens in a non-generic collection. So this is the second type of collection that we're going to work with right now. Okay. We'll discuss this in a minute. The question that should spring to mind is, why have two collections then? Why not just have one collection which is a generic collection? Why did they have a non-generic collection also and a generic collection also? And the answer to that lies in the fact that generics was not available in .NET version 1. When .NET version 1 came out, that time generics as a feature was not allowed in .NET. Generics came out only with version 2 of the framework. So in version 1, the only option you had was non-generic collection. But from version 2 onwards, you'll find that there is a better option, that is using generics. So all code written from version 2 onwards is using the generic collections. But you might face much older code or methods written before .NET 2, which are using the non-generic collection. So you need to know both, because in certain cases, this is what it's returning. In certain cases, returning generic collections. So be aware of both of them. Let's have a look at what the generic collections are. So first thing is the namespace. Instead of system.collections or generic, this changes to system.collections. Instead of system.collections, it changes to system.collections.generic. Right? If you compare the interfaces that we have, IEnumerable there has now become IEnumerable of T. iCollection has become iCollection of T. iList has become iList of T. And iDictionary has become iDictionary of T key comma T value. So why T key comma T value here in this case? Why are there two in this case?
Keys are also generic type.
Correct. So which is saying that your keys also can be of any type.
Yes.
And the values also can be of any type, which is why there are two T key comma T value. Somebody had asked a question yesterday that in a generic class, can we have more than one, data type supported out there? Just I was using only T. So can we have more? So this is an example of where you're having more than one. Right? The classes that you're using also have changed. Stack now has become stack of T. Queue has become queue of T. The array lists, the name of the class has changed. And now it's no longer called array list. It's called what? List of T. So there is no array list of T. There is a list of T. Right? The methods that you have will be similar to array list, but this is a slightly different version of this. Name is different. The sorted list remains sorted list. Then you don't have the hash table, is called a dictionary out here. And then these also have the T key comma T values out here. So these are the different classes that you'll be using in the generic collections. Questions, if any?
Sir, why are we using T value in generic, sir?
Why are we using the
T value in generic?
I'm not understanding your question. Why are
Am
we
I audible, sir? Why are we
You're
using
audible. I heard you also, but I didn't understand your question.
is there need to keep the value as a generic, sir? By default, it is generic. Now, in a non-generic collection, we are passing the value like int, strings, and
Correct.
like.
Okay, understood. So you're saying that there anyway it's taking object.
Yes.
But what did we just explain? Whenever you're storing this, supposing you did object.add here, supposing you did that here.
Yes.
All right. And what if instead of a string, for example, what if I was storing a numeric value here? What if I was storing a numeric value here? What will happen now? It's expecting an object. And what am I passing to it? I'm passing an integer. What is going to happen on this line again?
Boxing.
Again, boxing.
Yes.
So first thing is, it's going to be more efficient, but that's not the reason why we are doing it. See here, when you do this sorted list without the generic thing, you're saying it can accept anything.
Yes.
But there is no restriction. For example, if I wanted my values to only accept strings, if I wanted to only accept strings, this one does not have that feature. No? This one will accept any data. Agree with what I'm saying?
Yes, sir.
So
By using generic, sir, we can restrict the array list.
Correct.
Sorted list. Yes.
Correct. Correct. So each time that you're using it, you could specify what type of data your value is going to be. Now, there's nothing which stops you from giving the generic type as object if you want to store it as an object. That option is also available. But what can you also do? You can restrict it and say only this type of data should be available out there. So that gives you the reason why you're using the generic collection.
Yes, understood.
Sir,
Hello, sir.
sir, in non-generic
Sir,
collection,
okay.
sir, in non-generic collection, we are putting the objects on what basis it will be sorted in sorted list.
It generates a hash code from there. All right. It generates a unique hash code for every different object, and based on the hash code, it sorts.
Hello, sir.
Yes.
My query is regarding previous topic in which we use set by index method. So will it override at that index position or it will
Yeah.
shift the? Okay,
Override.
so it will override.
Yeah.
I thought it will shift the following the
No.
values by one.
No, try and understand. You're not giving it a key. Are you giving it a key? So how will it add it?
We are passing index and a value.
Right. But then what will be the key? If you're saying that it will add it, think logically, then what will be the key for that? You need to have a key also, no? So if it was adding it, if it was adding the value and shifting all values down, then what will be the key for the newly added value? That won't make sense.
Yes.
Okay. Short answer is yes, it overrides.
Yes. Okay. Thank you.
All right. So let's try these in our code. Right. You need to have a using on system.collections.generic, which I already have. I already have this using statement on top. So let's go ahead and use this. Now, what I'm going to do is similar methods that we had earlier. We'll add them here. So instead of array list, now I'm using what? List of whatever the data type that you want. So if I said list of T, for example, sorry, I just said T, list of int. What am I doing? Okay, list of int, for example, if I'm doing this. Now, when I do O dot add, right, this instead of taking an object, it's taken an int. Instead of this, supposing that this was a string, for example, then instead of taking an integer, it would now take a string. So depending upon the data type that you create, you create the list with, your add and all the other methods automatically change. And you've seen that with generics. So you know how generics works. Are we clear on this, please? O dot add, what can I add out here? Let's say 10. Okay. If I have to loop through this, give me the for each loop to loop through this. Instead of collection, this would be what?
O.
O. And what is one item in that collection now?
Int.
Int. Earlier it was what? Earlier it was object.
Object.
So you get this benefit of using some labels. Are we clear on this? Instead of what about the other methods? Will they be similar? Will you have similar methods to that? Yeah.
Yes, sir.
Right?
Yes.
Now you'll find that there are again these methods here. What did we tell you? What did I tell you? These are all extension methods, right? Which you see with the down arrow and which are going to be used in link. So when we come to link, we'll use these methods. For now, ignore those methods. All right. Main 3, main 4. So instead of array list, we use a list. instead of sorted list, we're using sorted list of t key comma t value. So let me take this out. Sorted list of, let's say I'm giving the key as an integer and the value as a string. When I'm doing this, what would it forcefully accept? Only integers and only strings as keys and values. Whatever, let's say s is equal to new sorted list. Okay, let me call this O so that I can copy paste the values from the earlier one. Right? When you're adding these values and you did O dot add, what does it take specifically now? Int and string based on what you're given on top. So that's how you could add the values. Help me loop through them. Help me loop through them. What is the collection here in this case?
O.
O. Now, when you use the non-generic one, you are using the dictionary entry, right? So in a non-generic collection, each element was a dictionary entry. The name of this has changed. It's no longer called dictionary entry. Instead, it's called key value pair. So key value pair also is a struct. And if you look at the angle brackets there, it's taking a generic type. What is the key of type?
Int.
Int. And value of type, in this case, string. So this will match with what you're given out here. Whatever you're given here is the same thing that you need to match out here. So that's the one change again. You know, the name of the class is, name of the struct is different. Instead of dictionary entry, you're calling it key value pair. Code will remain the same. What are the two properties that this item would have? Yes, item would have a key
And value.
and a value. Right? This code would remain the same. So you can try out these also with the sorted list. Okay. This was the non-generic collection stack and queue. The generic one, you could specify what you want to stack off. So let's say I'm saying stack of strings is equal to new stack of strings. And then the methods are the same. The difference now is when you say push, instead of taking an object, it takes a, takes an string as a parameter here because you're given this as a string. Similarly, queue of string is equal to new queue of string. And then the methods are similar as before. No changes there. Right? Okay. Now, one of the most frequently used classes here would be a list of something. The list of something would be the most frequently used class out there. Okay. Generally speaking, if you have your own classes, let's say, for example, if you have, let's say, an employee class or whatever other, custom classes that you're creating, quite often in your code, you will need to create a collection of these classes. So if I had to create a collection of employees, the most commonly used type of code would be, you would be creating a list of employees as we go along in our code. Instead of a list of integers, now I'm doing what? List of employee, whatever, let's say lst employees is equal to new list of employees. When I did lstms dot add, what does it take as a parameter here?
Object of employee class.
Object of the employee class. Let me try creating one new employee and right. What am I using here? I'm not using a constructor. What am I using here? What is this line of code using?
Object initializer.
Very good. Right. So it is not a constructor. I'm using an object initializer here in this case. All right. So this is how I could actually go and add items here into this list. Help me loop through this. What's my collection here?
LST aims.
LST MPS, right? Okay, so if LST MPS is a collection of employees, what does that make one item in that collection?
Employee.
Employee, right?
Yes, sir.
Right. So if I did item dot, what would I get with item dot? Item is of type employee. So what would I get with item dot?
Number, employee number.
Employee number.
Properties of employee. So in this case, employee number and name. Are we clear on this? So this is what you'd be working with most frequently out here. These type of loops and this type of code where you're creating a list of employees. So do try out something like this. And there's an assignment that I'll be sharing with you, which requires you to create a collection of employees and then manipulate that collection in certain ways. So I'll share that assignment with you later, but do try out code like this. All right. All right. I will be sharing this file also with you. I mean, it's nothing. It doesn't have anything much. Only thing, it has two links out here to topics that I'd like you to read on. So for example, one of the things that you have here is details about collections and data structures. What are the things that we have out here? What do collections do? Things that we have talked about, right? One of the options there is, see, I have covered only 4 or 5 collections, examples of collections, but they have given you a more comprehensive list. This collection is used for what? And this is the non-generic collection. What is the equivalent generic collection? Right? So what are the things that you can do with this? So these are the things that you're doing. When would you need to use what? So there's a one-line explanation of what each one of them does. All right. And then even things like, in terms of calculation, which works faster, which works slower, and all of this. So there's a more detailed discussion on collections out here, which is beyond the scope of what I have to cover with you. But I would like you to read through this. Okay. The other one, of course, is right. System.collections or generic namespace. So this contains all the collection classes that you have out here. And if you wanted to read up on that, then you can go and click on that and see this. Like, for example, I'm just giving you this. Let's say there's a linked list, all right? A linked list node, what is the difference between the node and the linked list or whatever. So all of these options that you have here, sorted list, sorted dictionary. What are the difference between the sorted list, sorted dictionary? So there are more explanation and more details about this. So these are 2 links that I would like you to read. In addition to this, in the ebook that I've given you itself, I mean, I don't know how many of you are reading that ebook as background reference material, but after I've told you, after I finish every topic, you should read the ebook as well, the chapter on the ebook. Like, for example, if I've done collections with you today, then ideally you should be reading up on collections out there, because I will not be able to cover up in the given time that I have. I will not be able to cover all the possibilities. No? I can cover the most important ones or the most frequently used ones. But there are so many more options that I may not be talking about. So just from your overall development point of view, for your overall knowledge point of view, it is important that you do a little bit of background reading also, in addition to doing this. So first is basically first finish this. What I'm giving you is the bare minimum that you must know. Without knowing that, you will not be able to code. But additional reading, please supplement that with reading up on your own. Okay, so I'll be sharing this file also, which has these two links which give you help on collections. All right. So let's move on beyond collections. Let's try out the next topic at hand. The next topic that we're trying out here is using delegates in .NET. Okay. So just before I get into the explanation of what it is in .NET, I'll give you a one-line explanation for those of you who remember your C++. Delegates in .NET are like function pointers in C++. So if you knew what are function pointers in C++, then you will immediately be able to understand what delegates in .NET are. If you didn't know function pointers in C++, if you didn't know that, no problem, no problem. This is for those of you who knew. Those who didn't know that, once you learn delegates in .NET, you will understand what function pointers in C++ also does. Okay. All right. So let's focus on in .NET what are delegates. Can you explain to me that the verb delegate, to delegate? What does that mean? Another meaning for that, or explanation of what does the verb to delegate mean?
To transfer responsibility.
Okay. Yes, correct. To basically assign a task to someone, to transfer responsibility is what he is saying. So you are asking someone else to do something for you. You generally delegate work, right? Like Nisha ma'am is not there today in the session, but the recording has been started. Who's starting the recording? Who starts the recording?
Aditya.
Okay. So he has been delegated this task, right? She has assigned this task to him, saying that you are responsible for what? For making sure recording starts in the session, right? Now, when we talk about, .NET, and when we talk about delegates in .NET, what do delegates allow you to do? Delegates allow you to call a function indirectly. So supposing you had a function that you wanted to call in .NET, let's assume, ignore the syntax. It could be a static void main and a static void display. All right. Supposing this is a function that you wanted to call. Normally, how do you call a function? Normally, how do you call a function? How do you call a function in your code? What do you do?
Function name, parenthesis.
Directly give the function name. So here you are calling the function in a direct manner. Now, what do delegates allow you to do? Instead of calling the function in a direct manner, you can make a call to the function via the delegate that you're creating. So delegate, actually, I use the term function pointer. It will point to the function. A delegate will point to the function. And instead of calling the function directly, you can make a call to the function via the delegate. So you assign the job of calling the function to the delegate. Are we clear on this? So that in a nutshell is what delegates do. What do they allow you to do? They allow you to call a function in a indirect manner. Okay. Now, first question that you should ask yourself is what?
So why do we need delegates?
Why? Exactly. Why do we need to call a function in the indirect? Why do we need that? If we can make a direct call to it, then would we need to call it in an indirect manner? And the answer is no. If you can make a direct call to it, then you don't need to call it in the indirect manner. Calling it directly is always the best option. Right? So if you have a choice between calling a function directly or calling a function via delegate, what is the better option always? Better option is what? Always
Calling
it directly. Calling it directly is easier, is shorter, right? Shorter in code, is not as difficult as calling it indirectly, is more efficient. Your code runs more efficiently. All of the above. So you calling a function directly always gives you most advantages. But there will be certain situations wherein you cannot call a function directly. And then in such situations, the only possible way is to do what? Is to call it indirectly with a delegate. Okay. Now, such situations we will see a little later. I mean, if you ask me right now, okay, give me a situation where this would happen, I can give you the answer. But those answers may not make sense to you. Like, for example, one of the answers I'll give you is that delegates should be required in event handling. So to explain this answer, I need to explain to you what is events, what is event handling. So at this point, I'm not doing that. All right, let me first talk about delegates. Once we have finished trying out delegates, then we will see the situations where delegates are, unavoidable. You have to use delegates. So if you want, I can tell you the situations, but at this time I can't explain them to you. So one possibility I said, where would you need delegates? One is when you would need it in event handling. Another place where you would need delegates is where you're calling asynchronous code. All right. So we'll see these situations as we go along. But if you want to make an asynchronous call, you will need to use a delegate. Another place where you'll need delegates is where the function to call can be received as a parameter. So using again late binding, function to call can be used as a parameter. So there also you could use delegates. All right. Another place is where, again, we are not trying this right now. When you're writing link queries, the query also can be written as a delegate. So all of these are different situations which are a little more advanced than the normal situation. In normal situation, what did I say? Most of the times we'll be doing what? Direct function call. See, all the code that we have written so far, we have not needed delegates. We're directly calling it. All right. But these specific situations that I mentioned, you will need to use delegates. So we'll look at these situations a little later. Because unless I explain to you delegates, I cannot explain to you how event handling would work. Or I cannot explain to you any of the other things how they would work. Okay. Now, what is the delegate? Let's get a little more technical. What is the delegate? The delegate is a class. The delegate is a class that inherits from system.delegate. Delegate is a class that inherits from system.delegate class. I'm going to change the statement a little later, but for now, just write it down as I'm saying. Okay. I don't know whether you remember, but we have mentioned the word delegates before. Can someone remind me where I have mentioned that word?
Instructs.
No.
Reference type.
Reference type, sir.
Reference types. Reference types. So when I gave you examples of reference types, I said all classes and their variations are examples of reference types. And the examples that I had given you was what? Classes, interfaces, delegates, arrays, object class, and the string class. That's what I had told you. So I told you there also, and that time also I told you that the delegate is actually a class. What additional information I'm saying? A delegate is a class that inherits directly or indirectly from the system.delegate class. But it is a special class. So you will not create a class with this keyword class. You will not say public class name. You would use the keyword delegate while declaring. So you'll say public delegate and the delegate name. Right? So delegate is actually a class and it has the signature. A delegate. Why are we using a delegate?
To make
What are we
indirect
doing?
call.
To make a call to a function indirectly. So the delegate would also include the signature of the function you have to call. All right. What did we say? The delegate is actually a class that inherits from system.delegate class directly or indirectly. And the delegate class would also need to have what? The signature of the function that you want to call. All right. To call a function, you need to create an object of this delegate class. To call a function, you need to create an object of this delegate class. Right? So let's, whatever we have said in words, let's try these same things out in code. All right. I'm going in for a new project. Even yesterday, I saw some of you all giving the same name of the project as the existing, concept or class. Like some of you all have named the project array. Yesterday's this thing, and you're getting an error in your code. So don't name the project with existing class names. There is an existing class called system.array. There's an existing class called system.delegate. So don't call your code delegate. Right? Do not call your project name as delegate. You can call it something else. I mean, you can call it whatever. Delegates, whatever. Any other thing. Delegate example, delegates, whatever. Bill Gates. You can call it whatever name you want to. Please don't give it existing class names. All right. So I'm creating this. Okay. What I want to do is I want to actually call a function called display. I want to call this function display from main. Easiest way to call it, we have learned this all our coding lives. Easiest way to call this is what? How do I call it? Call display. Yes.
So just write display.
Just by the function name. That's the easiest way. That's the best way. That's the most efficient way of calling this. But that's not what we're going to do. Instead, what are we going to do? We're going to call this with a delegate. So step one. Step one. Create a delegate class having the same signature as the function to call. Right? That's the first step that you're going to do. What did we say? The delegate is a class that inherits from system.delegate and it has the same signature as the function you want to call. That's what we said sometime back. Okay. Now, where can you create a class? Where in your code At what point in your code can you create a class? Yes,
Anywhere inside
At any
namespace.
namespace.
at the namespace level, one possibility. Any other possibility?
Say inside class also I can be.
Inside a class also, you can create inner classes also. So inside a class also, you can create a class. So where can you create a class? Either at the, or rather, let me ask you, where can you create a delegate? Either at the namespace level or within a class. If you create it within a class, you'll have to refer to it as class name dot delegate name. If you create it at the namespace level, you can refer to it directly. So I'm going to create it at the namespace level. Now, how do you create this? You would say public. Instead of the word class, you'll use the keyword delegate. And the name of the class. Let's say I'm calling this del1. But while creating the class, what do you need to also give? What do you need to also give?
Function signature.
Signature of the function. Signature of the function. So what is this function signature? Return type here is
Void.
void, and it has no parameters. So I'm going to do the same thing here. So the return type is void and it does not have parameters. Are we clear on this? What is this actually? What have I created here? This is a delegate class. Clear on this? Syntactically, very different from a regular class. What have I told you? That it's a class. How do you confirm what I'm telling you is correct and it's not bullshit? I said internally this is actually a class. Actually, this is creating a class that inherits from some class. How do you check that out?
By referring documentation.
No,
So
that's one way.
By making an object.
Internally, this is doing that. Behind the scenes, it is doing that. It is creating a class. How do you go and see that? How do you know the documentation is correct?
So I add DASM.
Thank you so much. You made my day. I've shown you ILDASM and I told you every time you learn a new concept, you should just do an ILDASM and see behind the scenes what is happening out there. So don't make me tell you this, but use ILDASM as many times as you want to. You'll understand a lot more of what is happening when you look at ILDASM. See, what is it doing actually behind the scenes? All right. So after you finish coding this, you go and see that you'll find that it has actually created a class for you. All right, let's come back to this. That was step 1. Step 2 is create an object of the delegate class, passing it function name as a parameter. See, my screen is, covered by the, the strip of, who has, all the people who are there in this training. Does that show you that view or no? Or you can see the whole screen of mine? Do you see the
Whole screen, sir.
You can see the whole screen?
Yes, sir.
Okay, fine. So you can see behind it because sometimes in my case it's overlapping. So I was just checking that. Okay, so create an object of the delegate class, passing it the function name as a parameter. What does this class say? This class says it can call any function whose return type is void and who does not have any parameters. So here you're not saying that this will only call display. Here it's only saying what you can call functions of this type. When you create an object, that is where you tell it that this one should be pointing to display. That this object will point to display. So help me create an object of that delegate class. Help me create an object. Come on.
So
Delegate
delegate
name.
So don't tell me delegate name. The name of the delegate you can see there. No?
DEL.
Code. When I'm asking
Del,
code, don't
del
tell me
one.
that in words. Tell me in code.
So
Del one.
del 1.
Del 1, whatever. Obj del, let's say, is equal to
New del 1.
new del 1. Right? Look at the symbol for a delegate. Look at the symbol for a delegate. It shows you a symbol of a briefcase. Right? I'll explain to you why briefcase later, but right now let's focus on the code. So del 1, and what is the signature of this del 1 is shown out here. What can it call now? A function whose return type is void and
Void.
no parapet. So look out here and it shows you this. So equal to new del 1, and what do you need to pass to this? What do you need to pass to this?
Function name.
Function name. What is the name of the function? Display. That's what you're doing out here. So at this point of time, obj del is pointing to display. I use the C++ term function pointer. So obj del is pointing to display. But this is not called display at this point. It's just pointing to it. So step 3 is where you call the function. So what do you do now? Call the function via the delegate object. Here in this case, what would you do now? Simply, instead of display, you are now calling what? Obj del. What is obj del pointing to? Pointing to display. So when you call obj del, what is it going to call right now? Here it will go and call display. Are we clear on this, everybody? So this is how you would go about doing this. Any questions, any doubts about this, whatever, 3-4 lines that we have written? Yes, clear? Let's try running this and see how this function gets called. So line 20 is where the function is getting called. Okay. Right, and so no big deal. You called the function with the help of the delegate object. Are you clear on this, everybody?
Yes, sir.
Can I take it further? Any questions beyond about this? All right. So let me simplify things for you. Can I simplify things for you? This is the actual code. Okay. Now, instead of doing it this way, alternatively, you can also write down code like this. You can also write down code like this. What am I doing out here? Instead of saying equal to new del 1 of display, what am I directly giving here? Equal to display. Display being the function name. I'm directly giving this. When you give code like line number 26, internally the compiler converts it to this line. Okay. So how does the compiler know what to do? Look at the left hand side. What is the left hand side of type? Left hand side is of type what?
Del 1.
Del 1. So it understands that you're doing equal to new del 1 of display. But you can write it in a much shorter way. Are we clear on this? So which syntax would you prefer? Would you prefer the longer syntax or the shorter one?
Shorter.
Shorter one looks better. So that's the one that I'm going to keep. But you might find some, syntax which looks like this somewhere else. It's the same thing. All right. All right. Okay, now I need your help. I need your help and participation to tell me what code this would be. So I have two methods here, let's say. I have two methods here. One is display, one is show. One is display, one is show. I wanted to first point to display and call display. And after that, I wanted to point to show and call show. So initially it should call display, then it should point to show and call show. Give me the code for that. So initially it's calling display. Next, what? How do I make it call show now?
So obj del equal to show.
Correct. And then after which?
Again call it as an obj del
OBJ
parenthesis.
in this case. Okay. So what is this doing now here in this case? Initially pointing to display and then pointing to show. This line here would now call show. Let's confirm that. So you got your display and then you got your show. All right. Okay. Now, every time you create a delegate, there is a certain hierarchy that is created. So there is the delegate class. There is your class. What is your class now called? Here, what have I called my class? Is del1. But your class does not inherit from the delegate class directly. Instead, there is one more class out here called multicast delegate. There's another class out here called as what? Multicast delegate. Okay. So your class actually inherits from this multicast delegate class. The multicast delegate in turn inherits from delegate. All right. And what does delegate inherit from, of course?
System dot.
Sorry?
Object, sir.
From the object classes. Everything inherits from object. So the hierarchy, when you're creating del1, this is the hierarchy. Del1 inherits from multicast delegate. Multicast inherits from delegate, and then of course delegate inherits from object. Now, what is so special about this multicast delegate? The multicast word indicates that at one time it can point to more than one function. Multicast means it can cast to multiple functions. Casting to multiple functions meaning what? It can actually point to more than one functions at the same time. So here, when I'm calling this code, right now, what is it pointing to? Here at this point, what is it pointing to? What is it pointing to?
So both display and show.
No, at this point, the highlighted code.
Okay. So now display.
Display function.
Only display. What is this pointing to? What is this pointing?
Show function.
Only show. Only show. But what I'm saying is it can point to more than one function at the same time. Now, how do you do that? Instead of doing an equal to, you do a plus equal to. And when you do a plus equal to, what are you doing? You're adding to that list. So initially, if this was pointing to display, plus equal to show means now it's now pointing to two functions, display as well as show. And when I call it on line 51, now two functions are going to get called. Are we clear on this? Both the functions. Which two functions? Display and show. Let's try this. So first time when I run this, when I call obj del the first time, what did it only call? Line number 47, what did it only call? Was display. Line number 51, what did it only call? What did it not only call, but what did it call now? Was display followed by show. Are we clear on this? Multicast delegates. Ability to point to more than one function at the same time. Now, how many functions can it point to? How many functions can it point to? Yes. How many can it point to? Multicast. How many? As many as you want to. There's no limit. What would happen if I now did this? Send me the output, okay? If I now did this again, let's say display, what will happen now? On this line, line 56, what is it going to call?
Show display.
Display, show, and display. Right? Let's try running this quickly. And this is what you got in the last function call. All right. Okay. If there is a plus equal to, there also should be a
Plus minus equal to.
Minus
minus
equal
equal
to.
to. So what if I did this now? What if I did this now? And instead of a plus equal to, now I'm doing a minus equal to. What do you think it would do when it calls line number 59? What do you think?
Show.
Show.
Show on display. Display and show.
So I'm not saying
Display
yes or
show.
no.
Display show.
Show.
Display
show.
and show.
So actually I got in first three answers, I got three outputs. Somebody said only show. So the person who's saying only show is assuming what? That all occurrences of display are being removed. That is one answer. Second answer, somebody said display show, which means what? That the last occurrence of display is being removed. That is what you're saying. And the third possibility was somebody said show and display, which means that the first occurrence of display is being removed. So you have actually covered all three possibilities with three answers. Let's confirm which answer is correct. And when you run this, you'll find that the output is showing you a display show, which is what? What is it doing now? The last added display would be removed first. See, functions are always on a stack. So it's like a last in, first out sort of a device. Okay, so that's what is actually being removed. Are we clear on this, everybody? All right, so you can have fun with this. Clear on this, everybody? All right. Now, when you do a plus equal to or a minus equal to, when you do a plus equal to or a minus equal to, it is actually calling these methods. So remember the delegate class? Remember the delegate class? Your del1 is inheriting from where? From multicast delegate, which inherits from the delegate class. So if you look at the delegate class, this has different methods out here. One is create delegate. It allows you to create a delegate. Then you have a combine, a remove, and a removal. So these are the four methods that you would be requiring out here. Let's look at some of these methods. What I'll do here is this del1 o1 or whatever obj del, let's say, is equal to display. What is this doing right now? What is this doing now?
Pointing to display.
Pointing to display. Now, instead of pointing to display, what I'm going to do here is I'm going to say delegate dot combine and look at what it takes as a parameter. It could either take two delegate objects as a parameter, or it could take params. Now, I have not shown you params, but if you look at what params does, it's taking an array as a parameter. Params is a parameter. When you use the keyword params, it means that you can pass as many parameters as you want. It's not restricted to 1 or 2. And whatever parameters that you are passing, supposing you pass 5 parameters, internally, this is converted into an array of, whatever, in this case, delegates that you're using. Are you understanding what I'm saying? When you say params, whatever parameters that you're passing are automatically getting converted into an array. So this allows you to pass as many params as you want to, as many params. All right. So let's see what I'm doing. I'm saying delegate.combine new del1 of display, comma, new del1 of show, and then I can add more if I want to. Are we clear on this, everybody? I can add more if I want to. What has this done for me out here? It has, combined both these delegates, or in other words, it's now pointing to display as well as show. Could I have passed 3, 4, 5, 6, as many as I want to? Yes, because of the fact that it's using params. Now it's giving me an error because delegate.combine returns a delegate. But on the left hand side, you have a del1 object. So you need to typecast this to a del1. Right? Because this here is returning a delegate. And on my left hand side, I've got a del1 object. So what is obj del now pointing to at this point? At this point, what is it pointing to?
So display and
Display and show.
Display and show. So what is delegate.combine like? What is this like?
Multicast.
Multicasting.
Is like plus equal to. When you do plus equal to here, internally, it is doing a delegate.combine. Okay. All right. What if I want to add one more? What if I want to add one more? I could do something like this. Obj del is equal to, I'll copy this. Sorry. Instead of new del1 of display, I could now say what? Obj del itself. And let's say new del1 of display. What is this now pointing to? What is obj del now pointing to? What is it pointing to?
so del object of del1 obj del.
So what is obj del initially?
The display and
and
show.
show.
So what functions is obj del now pointing to? This is display, show,
Display.
and again display. Right. So I'm doing this out here. Right. So I'm just showing you how it's proceeding. Now, if I want to delete one of the functions, what will I call now here? Delegate dot. You have two methods. One is remove and one is remove all. So supposing I use remove, it says firstly from which delegate you want to remove. So you want to remove it from obj del. You want to remove it from obj del. And which delegate you want to remove here? Let's say I want to remove display. So this is the one that I want to pass to it. New del1 of display. Right? Okay. This again returns a delegate. This returns a delegate. So I'll do the same thing that I was doing earlier and store it back into obj del. At this point, after this point, what is it going to do out here? What is this going to do? This is like what? Remove is like what?
Minus equal to.
Minus equal to. So what will this do now in this point? Call what?
Only display and show.
Display and show. But instead of doing a remove, what if I had done a remove all? remove all. What do you think that will do?
All
Come on.
function calls will be removed.
All function calls of display will be removed. So at the end of it, you're left with what now here?
Show.
Yeah, you know what? I'm not calling it that. I forgot to put in this line in the copy paste. I'm so sorry. Yeah. So at the end of this, what will you be doing here? At this point, what will you be calling now?
Show.
Only show.
Show.
So when you're trying this out, try it out both ways. Try it with remove also, try it with removal also, and see how it works. So you can try running this code. And in this case, the last one would only be show. But if you had given remove instead of remove all, that would have worked like minus equal to. All right. Are we clear on this?
So can we why do we need to write new del display as we have written in the upper code? Can't we just write display and show like this?
Syntactically, it doesn't work.
Okay.
Because it expects a delegate as a parameter, and it doesn't allow you to do that. So
Okay.
the syntax doesn't work. It forces you to write it this way. So your suggestion was, can we not just give display or can we not just give show? Is that what you're saying, right?
Yes, sir.
So it doesn't allow me that. All right. So this is what we have done with multicast delegates. This is what we have tried out here. We're going to have lots more to do with delegates. This is just the beginning. But we have a 3.5 hour session today. We'll take a break at this point. We'll come back from the break and we will continue with more examples on delegates. Okay. So it seems to be a good point to take a break. It's almost 10:45. I will start the session at 11:15 sharp. Please don't be late. A lot of people today, were not in the session at 9 o'clock when the session began. So I plan to start at 11:15 sharp. And if you're not back at that time when I start the session, I will not allow you in the session. All right. So please
sorry.
be on time.
One last question. So as we already have the display in OBJDL is already pointing to three things at line 72, that is display, show, and display. So when we are trying to remove it at line 76, why do we need to write new del as in it is already present, right?
Because then what you can do is you can have an explicit reference of that delegate. So you actually do this. You say del1 o1 is equal to display. And instead of calling new del1 of display, you pass o1 here. You pass o1 here. And while removing it, you then again do o1. You could do this.
Okay.
Right? Then you can avoid that new. But since I have not done that, therefore I'm using this syntax.
Okay, sir.
All right. 11:15 sharp. I start with this session. I continue with this session. Please be on time. Join in a couple of seconds earlier, at least a minute earlier, maybe. Okay. See you then. Bye for now.
Yes, sir.
In case you have any queries or questions, we can take that before the session starts.
So,
Yes.
so in the book that you have mentioned, so there was a statement where it was written that delegate is derived from multicast delegate.
Yeah.
So is it the correct statement, or
I should just show you the hierarchy.
so you wrote delegate above multicast delegate?
So this is my del1 class. This del1 is my delegate class.
Acha, okay,
So
that
this
in that way.
inherits from multicast delegate.
In that way, okay, okay, you got it.
And
Okay.
multicast inherits from
Delegate.
system.delegate.
Okay.
See, there is in a good you mentioned that in the book or in any place, not just in the book, anywhere. I'll take you to my code out here, okay? What did we call this? What did we call this? Del1, what did we call it?
Delegate class.
Correct?
Yes.
Right? We call this a delegate class. What do we call this?
Yeah, passing the function to the delegate object.
Right. So we are calling it, I am calling it a delegate object. Okay. So for your understanding, we said that this is the delegate class and this is the delegate object. All right. Now in the book or in MSDN or anywhere else that you read, they call this the delegate. They call this the delegate. They call this also the delegate. And they call this also delegate. So when they say delegate, it could mean one of three things. It could either mean system.delegate, or it could mean what we call the delegate class, or what we call the delegate object. So this is unfortunately, there is no clarity from their side on what they mean when they say the word delegate. But when I talk to y'all, I explicitly say that this is the delegate class. And I explicitly say that this is the delegate object so that you understand what is happening. You will not find this clarity in a book or even in MSDN. MSDN also they're saying what? Delegate, delegate, delegate. So then it's up to you to decide what they're referring to in that sentence. Okay?
Yes, sir. Yes, sir.
All right. All right. So, any other queries before we begin?
Yes, sir.
Yes. No other queries? Okay, so we have just seen before the break, we have seen, multicast delegates and, delegate.combine, delegate.remove, and so on and so forth. As you must have guessed by now that display is my favorite function. Okay, my all-time favorite function is display. My second all-time favorite function is add. Right? My second all-time favorite function is add. So this is the code for add. What do you think I'm going to ask you to do? What do you think I'm going to ask you to do?
Create a delegate.
Parameterize delegate.
Correct. So help me call this function with a delegate. Go ahead and help me with the code. How do I call now add with a delegate? Can I use the same delegate class that I've been working with all along?
No, sir.
No, sir.
Why not? I use del1 for display and show both.
But sir,
Why can't I use it for add?
method signature.
Signature is signature.
Because the signature is different. Moment the signature is different, then you can't call it. So what is the first step? What will you need to first do to call add? What will you first do? First step is
Create a delegate class.
create a delegate class. So help me create a delegate class. Give me the code for that.
Public delegate.
Public delegate
Carry on.
Int.
return type int.
All right. Now you may give me the right answer. You may give me the wrong answer. I'll show you a way of never making a mistake. You'll never make a mistake with what I'm trying to show you out here. So look here. I'm just writing public delegate. Then I go and copy paste this add method that we had, the signature of the add method, including the return type. Don't leave out the return type. Okay. So from the return type, copy this and paste it here. Right. And then of course the semicolon here. So this way you'll never make a mistake. The only thing is, of course, you might need to change the name of the delegate class. Whatever the name of the class, you change that. But the way in which you write that code would be exactly the same as what you're writing in the method. Obviously, it doesn't have any code body, but that's the method signature that you're giving. Okay. All right. So that I've created the delegate class. Now what? Now help me call the delegate object. Let me call add with this, with del add. Help me. Give me the code, please. How do I call add with del add?
Del add.
Del add object.
Del add. Whatever.
Obj.
Del add is equal to
New. So or in any way like add. Directly add. Directly we can say add.
Yeah. So you can give new also. There's no harm in giving new, but shorter, simpler way is what? Directly the function name. Now, while giving the function name, don't try to pass any parameters. Here is not where you're calling the function. Here you're just saying what? That this one points to add. So nowhere in here you will need to give in any function parameters, parentheses, nothing. Just the function name. Okay, now how do you next call it? What will you do in that case? Let's say int answers, right? And answer is equal to yes. Obj
del add.
calling add
with
parameters.
Right, with this. So where you're calling it, that's where you will pass the parameters. And then of course print the answer. Alternatively, you could have done this. I mean, right? So here, what are we doing here? In this case, directly we are printing the values. So that's how you could use this. All right. So if you try running this on both of them are calling add. Both the method calls are calling add in two different ways. All right. Are we clear on this? So the point I'm making is this does not change. You still give only the method name. And where do you pass the parameters? Only when you're calling the function. Only when you're calling it, that's where the values would come. Now, when you're doing this, if you're having functions that have a return value, if you use multicast delegates, then they behave slightly differently. So I'm not telling you what is the difference. What I would like you to do here is call a multicast delegate with a function that has a returning of value. So what I'm asking you to do is this. For example, just like let's say you had add, you had one more method. Let's say subtract, which had the same parameters. Now, if you use multicast delegates and if you call add and subtract, I would like you to try that code out and come back and tell me. Maybe in the lab session, you can tell me, okay, I tried it out and this is what happened. What would be the output there? Will it allow you to do that? Will it not allow you to do that? What will be the output? What will be the result? That is what I'd like you to try. So do you understand what I mean by multicast delegate? delegate that points to more than one function. Okay, a delegate object trying to point to multiple functions. If you had a return value in that function, what would be the output? This is something that you need to try out. Are we clear on this so far? Okay. Now, if you notice, you all didn't ask me the question, but I've been asked this question often in other batches that, why have you kept these methods as static? What is the reason for keeping them static? And what is the answer? Why am I keeping them static?
So that they can be called from anywhere.
So to call these functions, I didn't need to create an object of that class. So the next question that came up was, how do you call a method that is not static or which is not part of this class? How will you do that? So let's try doing this. What if, for example, if you had these methods in a different class, public class, class 1, right? And let's say that display and show were in different classes. And let's assume that one of them was static and one of them was not static, right? Let's assume these were the methods that you are calling. I've just moved these methods to a different class and I'd like you to help me with that code. Yes, please. Please help me call that code. Help me call display first. Help me call display first. Come on.
Class 1 dot display.
Darling, with a delegate.
Sorry, sir.
But to give you credit, the answer was right.
Yes.
Okay. But now I wanted to the delegate. First thing is del1, yes, O1, let's say, is equal to, what will this be now?
Class 1 dot display.
Correct. The same thing that he was mentioning. Instead of just saying display, which is in the same class, now the display is in a different class. So that's the only change. And then, of course, you'll call it as O1. Okay. How about the non-static method? The show method. How will you call that? To call show, what will you need to do firstly?
Object of class 1.
Correct. Create an object of type class 1. So class 1, obj class 1 is equal to new class 1. And now help me call that other one. Help me call show, show from there. Come on.
So O1 equal to class plus equal to or equal to?
Equal to, let's say equal to.
Yeah, and then OCLS1 dot show.
So that's the only change that you have. Other than that, everything else is exactly the same. The only thing that is different here is what? If it's a static method in a different class, we'll say class 1 dot method name. And if it is a non-static method, you'll first need to create an object of that class. And then while making it point, you'll have to say whatever, reference name dot method. Okay. Other than that, everything else is exactly the same. Right. So that's generally a question that comes in from quite a few people. So here, either you know the answer to it or you didn't think of the question. So whatever.
So I was going to ask, but then you already asked that question.
Okay, good. No, good. Ask the question then. Did you know the answer to it though?
No, sir.
No, अरे क्या कौस्तुभ?
सर नो मतलब इतना सोचा नहीं था ना उसके बारे में कि लाइक ठीक है इसलिए अगर सोचता तो आ जाता था.
I just couldn't understand the last two lines of what you said. I don't know, you were speaking some foreign language.
English. Speak in English.
Okay. So he was doing what happens in the lab. In the lab still, when you're talking to yourself, you'll start off talking in Hindi and Marathi. Then you suddenly, sir, come. Then you switch to English. So anyway. So we have tried out few basic things with delegates. All right. Okay. We're going to try some funky code. Next with delegates, we're going to try some funky code. Right. So let's try some funky code. I'm going in for a new project. So adding a new project and console app still. All right. Now, let me take you back to the same example. I'll copy paste some of my code so it will help me do this quicker. If I had to call display, what did we first need to do? What did we first need to do?
So in delegates,
Yeah, in delegates, calling using delegates. What did you first need to do?
create a class, delegate class.
We needed to first create a delegate class that matches the signature. Now, if the function that I want to call had a different signature, then what would I be forced to do again? Supposing this next function, one more function I want to call, let's say add, and it had a different signature, then can I call it with the same delegate class?
No. We have to create another delegate.
So we have to create another delegate class. So which means that as long as your functions keep changing, you'll have to keep adding those many delegate classes. Right? Now, this can sometimes be quite bothersome. We have to create a new delegate class for every new function call that we want to make, every different function that we want to call. So for commonly used functions, okay, .NET provides certain inbuilt delegate classes which you can use. So you don't need to then go and create your own delegate class. You can use the delegate class that .NET is providing you. Okay. Now, one such class is called as action. What is action here? What is action here? It's a delegate class. You see the symbol for the action? Yeah, the briefcase. Okay, just 1 minute before we go into action. Why briefcase? What is the logic behind keeping a briefcase out there for a delegate?
It contains a class.
Okay, I'll tell you the logic behind it. The word delegate in English can be used in two forms. Can be either a verb form. Verb form meaning what? You delegate something to someone. You ask someone to do something to you. You assign a task to someone. That is one form. Delegate in English can be also used in a noun form. So what does the noun form of the word delegate mean?
Person.
Critical.
A person, yes.
Officials.
Like a chief.
Basically a representative.
Yes.
Somebody who's doing the task for you. Like a company assigns a delegate to a conference. So if there's a conference going on, the company assigns one of its employees saying, okay, you go and represent the company. So he becomes the company delegate. So the word delegate there is a representative. All right. And he's doing the task for someone else. Now, these delegates, these company delegates, generally, if there's a conference to attend, they fly in the morning. They go to that whatever other city, for example. They fly into the conference in the morning, attend the conference the whole day, and then fly back in the evening. So they carry a suitcase with them where everything that they need. Nowadays, of course, they carry the laptop. But in the older days, they would carry a suitcase with them, a briefcase, not even a suitcase, a briefcase, which contains all their things. So typically, when you look at a delegate, you could see him in a suit, wearing a suit, pant, whatever, and carrying a briefcase. So that's the idea behind this suitcase out here. Okay. So every time you see a suitcase, you know that that's a delegate. So that's besides the point. But anyway, we were talking about action. So action is a delegate. What is the signature of action? Look at the signature of action. Look on the right hand side, signature. The return type is
Void.
void. And what parameters does it have?
No parameter.
No parameters. So action is an inbuilt delegate which can be used to call a method that has a void return type. I'll show you other variations of action. Can you see that other action? Action with angle brackets. What are the angle brackets there? Angle brackets using generics. So I'll show you the other action also. But this action is used to call a method that has no parameters and has a return type of void. So help me call display. Display also has the same signature. Action, let's say O1 is equal to display. Right? And how do I call this now? Simply O1. What did I need? What did I eliminate out here? What did I not need to do?
Our own delegate.
Our own delegate class is not required. You can use action. Right? So what is action used for? Action is used to call all methods whose return type is void. Any method whose return type is void can be called with action. And I'll show you other variations of this. Let's say, for example, just took a string as a parameter. Right? Just took a string as a parameter. Now, if I wanted to call this function, right? Again, what is the prerequisite?
You have to create delegate class.
No. For action, what is the prerequisite? Function needs to have a return type of void.
Voids.
You can
No
use
parameter.
yes. No parameters. Not a. I'll show you in the second example. Second one, I'm showing you a function that is one parameter. I'm using the other action, and this other action is a generic one. So what does it take as a parameter? It takes a t as a parameter, and it says in t. In t meaning that it's a parameter to it. When you see the word in out there, that means it's a parameter. And if you see the word out, it means it's a return value. So in t. So in this case, I can call a function that has one parameter. Right? So in this case, this is calling display which has one parameter. So string, right? Whatever. Let's say O2 is equal to display. Which display is this one? Which display is this one? The one that is a string as a parameter. And to call it now, I can call it as O2 of whatever value that I want to pass. Are you clear on this, everybody? So I could call it this way. Or let's take another example, just to be a little clearer. How do I call this display now? Help me with this. Action, carry on. What are the parameters of this?
String and int.
String and int. So if we look at action, it has up to 16 overloads. Look at this. Now in this case, what is this one taking? Only one parameter. Second one, 2 parameters. Next one, 3 parameters, and so on. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to 16 parameters you can call. No more after that. 16 is the maximum you can pass, right? So you can use it to call any function that has a void return value and up to 16 parameters. What is the function at 17 parameters? What is the function at 17 parameters? Then what? You can't use action. Then what? Write your own delegate. Write your own delegate. Firstly, don't have a function that takes 17 parameters. What are you doing with 17 parameters? Oh my God, bad design. But if at all you do have that, then you can write your own delegate class. Okay, help me call this one action of, what are we doing? Action of, yes, string, comma, int. whatever, O3 is equal to display. Right? And I could now call O3 and pass to it a string and a integer. Are we clear on this, everybody? Questions, if any?
So as in delegates, we can combine two delegates. So can we do that in action?
Signatures here cannot be different. Same signatures you can combine.
Okay.
Right? Because on the left hand side, you have a particular delegate. So the signatures are different, then you can't combine it. But otherwise, whatever you're doing with any delegate, you can do it here with this. Only difference here is what? This is an existing class instead of you creating your own delegate class. That is the only difference. Otherwise, whatever you learned so far, all those concepts are applicable here also. Clear on this so far with action? All right. Let's go back to my second favorite function, which was add. With add. So I'm going to call now add. Can I call add with action?
No.
Why not?
Return type.
I called
Return
display
type.
with action.
Return type, sir.
Return type is
Condition.
not void.
Yeah. So action can only be used for calling functions that have a void return value. The moment your function has a value other than void, you cannot use action. Okay. So what do you use then? There's an alternate, there's a second delegate here called as func. Func. Right? So func, let's see this. What does it take as a parameter here? What does it take as a parameter? Yes, out t result. What does out mean?
Return type.
That you are giving the return type here. So if you want to call a function that has no parameters and a return type, you can call it this way. Right? Look at the overloads to this. Tell me what this would do. Tell me what this overload would do. In t, comma, out t result. What does this indicate?
One parameter
One parameter,
and one
that is in t, and out t result is the return value. Okay. Next one again. Carrying on. What is this now? In t1, in t2. What does that indicate?
Parameters.
Two parameters and one return value. Are we clear on this? All right. And then this continues. It's 3 of 17. So what is this taking? 3 parameters and a return value. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Up to 16 parameters and a return. Right? So this is how you can call func. What would I need to write for this one? Can you help me to call add func of?
Int, comma, string. Sorry, int.
Int, comma, int, comma, int. What are the first ints? What are these two ints? These are the parameters. And the last parameter, last one here is always going to be the return value. Return value comes at the end. So func of int, whatever, let's say O1 is equal to add. And then if you have to call add directly, you can do it this way, O1 of whatever, 10, 20. That's actually calling this. Are we clear on this? That was how you're calling it with func. I promise you I'll be writing some funky code. Okay, so here's your funky code. Okay, just to give you more examples, can we Try calling these methods. Static int do something string a comma decimal b. I'm just sort of writing some method here just so that you get used to this. Help me call this method. Help me call this method with func. Come on. Do something. I want to call it.
Decimal.
Func of firstly
String decimal.
string and
Decimal.
decimal, and return
Comma
type
int.
here is
Int.
an int,
Int.
right? Whatever. O, what is it? 2 is equal to do something. And then do call it, simply do this O2 of string, comma, decimal, and this is what is written. This by default, it takes it as double. So you'll have faced this problem before. You just need to put an M out there, which converts it to a decimal. Otherwise, other option is what you do. You call a convert dot to decimal. You can do that as well. Okay. Right now, I'm just writing down some other code out here. Right. So if you look at the last function that I have here, the function that I've written called is even, which is I'm checking for what if a modulus 2 is equal to 0, return true, otherwise return false. Okay, so all that is doing is checking whether the number is even or not. Help me call this one with func. Help me call this one with func. Is even, I want to call it. Func of what?
Int, comma, bool.
Int, comma, bool, whatever. O3 is equal to is even. Right? And console.writeLine O3 of whatever value that you pass, it'll return either a true or a false. Right? So let's quickly run this and try this out. So we're calling add and then whatever, do something and is even. So these are the outputs that you got for all of these. Questions, if any, with any of this code that we have tried so far? So what are the basic difference between action and func? Action and func.
Return type.
Return type is void.
Func is, yes, action is used for calling functions which have a void return value. Func is used for calling functions that have a non-void return. In both action and func, you can call it with up to 16 parameters. All right, this is what we have seen so far. Now, if you look at this code out here, if you look at this code, is even, this function takes one parameter and returns a boolean. Now, this type of code of functions that take one parameter and return a boolean happen quite often in LINQ. We will be writing LINQ queries a little later as we go along. And this feature of a function taking one parameter and returning what? Return type is what? Fixed. What is the return type?
Boolean.
Bool. Parameter can be anything, but return type has to be Boolean. Such type of functions will occur quite frequently in .NET, especially when you're writing LINQ queries. Now, for such specific functions, instead of writing with func, there's another inbuilt delegate called as predicate. So predicate is a delegate which takes this signature. Look at the signature of predicate. Can you see from the IntelliSense? What is the return type for predicate? Return type is
Bool.
Bool. And what is the parameter to predicate? What is it taking it as?
One
Int.
parameter.
Meaning what? One parameter which can be of any type. So help me call is even with predicate. Help me call is even with predicate. Help me call that. Give me the code. Predicate. Yes.
Int.
Into, in angle brackets, what?
Int.
Only int. Why not bool?
Default return type is Boolean.
The return type is fixed as Boolean. That cannot change. So in func, you have to give both. You have to give parameters and return type. But in predicate, the return type will always be Boolean. So how many parameters can you give in predicate? Only one. Predicate of int, whatever, 04 is equal to is even. Right? And calling it will be the same thing. The way in which you're writing it here, that's the same way in which you'll call it. 04 of whatever, 10. So this is going to give you either a true or a false. Are we clear on this, everybody? On predicates? So predicate will be used in a specific situation. Function that has a return type of Boolean and any one parameter. Questions, if any, about action, func, or predicate? All right, so moving ahead, henceforth, instead of creating your own delegates, you first try how to create a delegate class. You should know how to do that. But instead of creating your own delegate class, what will be the preferred option? You will either create action or func or predicate. These will be the things that you'll use for your normal code that you're working. All right. Let's go on for a new project. Okay. We're going to look at a fresh concept or another concept called as anonymous methods. So what does the word anonymous mean? Anonymous means what?
Method which does not have.
Without name.
Somebody who doesn't have a name. And if you're talking about an anonymous method is a method that does not have a name. So if you are going to call a method, normally you've been calling a method with what? With method name. To call a method, you need its name, right? Supposing you got a function called display, you're calling it with display. But if you have a situation wherein you have a method that does not have a name, then you obviously cannot call it by its name. Right? How will you call that method? Like, what will you refer to the method? How do you say, okay, array, bhai sahab, what do you want to call him? So the only way of calling an anonymous method would be using a delegate. So you can have a delegate object point to that method and call that method with the help of the delegate object. Are we clear on this, everybody? So that's how you're going to call this anonymous method. First question that you should ask yourself is,
Why?
Why we use?
Why do we need an anonymous method? All right. So an anonymous method is like a local function. The anonymous method that you write will be like a local function. And quite often in your code will need to call some other function, will need a delegate actually. So instead of creating a new function, you can create an anonymous method. And it has the same advantages as that of local functions. So the situations which we'll need in our code, we will come across them as we go along. Especially in link. Anonymous methods are used majorly in link. When you need to write a function and give you some extra features in that function, which normally you would not be able to do otherwise with regular functions. So let me show you anonymous methods and then we'll discuss the possibilities of where they could be used. Now, I don't need to write this function. Okay, I don't need to write this function. I'm going to create a function that doesn't have a name. Right? So I don't need to write display. I'm repeating again. I don't need to write display. I don't need to do this. This is not required. This is not an anonymous method. But just to show you a comparison, of how this will call, help me call the method with a delegate. Help me call this display with a delegate.
Action.
Action.
Action O1 is equal to
Display.
And then you would call what? You would call O1. So this is how you're calling it. Is this method an anonymous method?
No,
Is this
sir.
method an anonymous method? No, this is not an anonymous method. Now, if you want to write an anonymous method, see what I'm going to do. Whatever code you're writing for a regular method, what I'm going to do is I'm going to copy that method. Let me make a copy of this. 1 second. I just want to show you how this works. Okay. I'm going to copy the method. So what am I copying it from? This time, don't take the return value. Take it from the method name up to the end of the method. All right. Copy this method. And when you're saying action O1 equal to display, instead of display, paste this code. And change this method name from display to delegate. Delegate is a keyword which indicates an anonymous method. So this what you got here was an anonymous method. I don't need display. Display was just to explain to you how it worked. But this is an anonymous method. Are we clear on this, everybody? Clear what we have done? What have we done? We have written the method in there itself. This method does not have a name. Instead, what keyword are you using to describe it? Just delegate. Okay, understood? Questions, if any, at this point? If I run this code, what will happen now? When I call O1, O1 is pointing to the anonymous method. What will it call out here on O1?
Sir, it will print the line number 16. A non-method called.
Yeah. So whatever the code in that within that code, that you're given in there, that will be the code that will be called. Questions, if any?
So what if a method returning the something value?
So we'll take my second favorite method.
Yes.
Which is add. Right? So he doesn't want my first favorite method. He wants my second favorite. Please help him.
By
What will you do?
func.
O2 is equal to delegate.
Func, firstly, don't dump, na? Func of what?
Int.
Func of what?
Int,
comma, int. Agree?
Yes.
First two are the parameters and the last one is the return value. So func of int O2 is equal to, I don't want to add, of course. But simple way, what would you do? Simple way, if you have to write this down, then what do you do? If you have got the method, add, what am I going to ask you to do? What am I asking you to do? Simple way of not making a mistake. Copy from
Copy
where?
paste.
From where? From the method name. Don't take the return value. This time don't take the return value. Copy the method name, paste, and replace what? Replace what?
Add with delegate.
Delegate keyword.
The method name with the keyword delegate. All right, little formatting, and call that method. So console.writeLine O2 of 10, 20. Did we need these methods? Did we need these methods? That was just to show to you what is happening. Just initially, just so that you understand, you don't make syntax mistakes. I'm showing you how this works. This is your delegate, calling it via the delegate. If you run this now, of course, it gives you both the methods, anonymous method called and 10 plus 20, giving you 30. Acha, let's try calling the other one. Since you asked me for one method, I will ask you for one method. Fair enough. This is the method I want to call. Okay, this is the method I want to call, but I don't want to do the copy paste. Tell me what did I do? I don't want to do copy paste. Do it without copy paste. Tell me, give me the whole code. What can I use to call that this sort of method?
Predicate.
Either func or predicate. Both of them will work. Agree? All right. So which one do you want to use? I'll use the one that you want.
Predicate.
Okay. So help me. Predicate of int whatever O3, right, is equal to, now without copy paste, can you do this?
Delegate.
So instead of the method name, you're giving what? Delegate, and then whatever the parameter there, int a, and then the brackets. Don't forget to give the semicolon. Why don't forget to give a semicolon? Because the statement has started here and then it ends here. So this is what we're doing. It's giving an error right now because there's no return value. So give me the return value. Okay, can I just copy paste? Help me with the code. If what? A modulus 2 equal to 0, then return true, else return false. All right, so this is what we are doing out here. And to call the method, of course, you'll do it as what? Console.writeLine O3 of whatever value you want to check whether it's even or not. So that's how you're calling an anonymous method. Okay, I've shown you the copy paste method just so that if you are stuck, you know what to do. But otherwise, just type it out and like you would give the method name, and instead of the method name, you're giving what? You're giving delegate. Questions, if any? All right. I said that local functions, in fact, the syntax also, if you look at this, where you're defining the function within another function, correct? You're defining this function within the main function. So the local function, sorry, the anonymous method is like a local function. And what is the advantage that you get in local functions? What can local functions do that normal functions can't do? What can you do with local functions? Yes.
We can access the local variables inside the local method.
Correct. So if you had some local variable out here, if you had some variables defined in this function, these could be accessed inside that local function. Now, similarly, for a anonymous method also, you will be using this. So console.writeLine, and then I can print the value of a. Here is the local variable defined in here. Are we clear on this? So this is accessible out here. I think I might have something called a later. Yeah, so I've got this as a, so I can't have two having the same. Let me call this as x. Right? Okay. So this is one advantage that anonymous methods have, similar to local functions. And what did I say? Where would these anonymous methods be used a lot of? Mainly in, I've given you one example, mainly in link, and secondly, again, something that you've not seen so far, in event handling. So in both these places, you'd be using this type of code. So be comfortable with it. It's going to be coming to you quite often. Are we clear on this? All right. All right, let's try out the other example. All right. What we're going to try out next in this example is lambdas. Right. So what are lambdas? Lambdas are also anonymous methods. So what are anonymous methods basically? All anonymous methods are what?
Local functions.
No, they are methods that don't have a name.
Name.
They're similar to local functions, but if somebody asks you what is an anonymous method, your answer should be a method that does not have a name. And therefore, it can only be called through what? If it doesn't have a name, it can only be called through a delegate.
Delegate.
Okay. So I'm saying all lambdas are also anonymous methods, meaning what? You can, when you write a lambda, you're writing a function that does not have a name. But lambdas are given as expressions. When you write this lambda function, you're not writing a full-fledged function. You're writing it in a much shorter form in a lambda expression. And these lambda expressions are much more compact, shorter than writing a regular function. So like I said, there'll be a lot of places where you're writing, anonymous methods. And if you're using a lambda, then you can express this anonymous method in a shorter format. So the syntax of a lambda, I'm sure you know what's a lambda. Syntax of a lambda is much more, easier. Not, I wouldn't say easier. I would just say it's much more compact than a regular function. So let's try writing a few, lambdas for this. Let's assume this is the function I want to write. Static int, let's say make double, which takes an int as a parameter. And all that I'm doing here is I'm saying return a into 2. So this is what I want to do. Okay. Help me call this function with a delegate. Help me call this function with a delegate. What will I do?
So func.
Func int comma int, carry on. O1 is equal to make double, right? And then you can call console.writeLine O1 of whatever value that you're passing, and then this would return double of that number. So if you pass 10, you will get back a 20. Now, if I had to do the same thing through a lambda, see what I'm doing. See how I can express the same thing in a much more shorter way. So I'm saying func of this part, I'm keeping the same. Func of int. Instead of O1, I'm calling it O2. Instead of O1, I'm calling it O2. Now, what I'm going to do is I'm going to replace the code for the function with a lambda. What is the first thing that you would require in a function? You need the name of the function, right? But the lambda, we said, is an anonymous method. The lambda also doesn't have a name. A lambda is a shorter way of writing an anonymous method. So I'm not taking make double out here. I'm leaving that out. Instead, what am I taking? I'm looking at the parameters. So how many parameters does this have? Has one parameter. What is the name of the parameter?
A.
I'm taking A. Now, while giving the parameter, here I'm not giving the data type of the parameter. I'm just simply saying A. The data type of the parameter will be assumed or will be inferred from the left hand side. What is the delegate signature? What are we saying here? What does it take as a parameter? It takes an int as a parameter. So A is automatically inferred as an int. Are we understanding this? I'm saying what is A? A is the parameter. I'm not going to write int A. Why am I not going to write int A? Why not write int A? Because here I'm already saying that it's an int. So I don't need to say int A. Instead, what am I giving? I'm only giving the name of the parameter. The parameters are over. Correct? Then you give the lambda expression. So this is the lambda expression, equal to and greater than. That is the lambda expression. And after this, you give the return type. You give the return code. What is the function returning? What is the function returning here?
Int.
What? Yes, A into 2. But I will not use the return word. I will directly say A into 2. I will directly say A into 2. And this here, what I've given here, is an example of a lambda expression, which is the same as the function that I've written out. So if you notice this is much more compact than having to do all of this. Do you agree with that or not? The lambda that I've given here is so much more compact. How do I call it? How do I call it? The same way that you were calling the earlier one, which is O2 of whatever 10. Are we clear on this? So that's how you wrote a lambda. Questions, if any, at this point? Line number 51. That's your lambda expression. Right? Let's run this. And in both cases, it gives you 20. Did I need this function, make double? Did I need this?
No, sir.
No. So can I remove this? I mean, just in case you're wondering what is happening there. I'm just removing that. I don't need that. All right. Now I'm going to show you a slightly different syntax. Let's say O1. And I'm giving these parameters in parentheses. So what was A out here? A was a parameter. I'm giving this in parentheses. So both of these, line number 49 and line number 50, are exactly the same syntax. There's no difference in there. All right. But if you are having more than one parameter, if you are having either 0 parameters, either 0 or more than 1, anything other than 1, then the parentheses become compulsory. Then the parentheses become compulsory. So if I had to, for example, write my favorite function, okay, I've deleted that. If I had to write this function as a lambda, help me write add as a lambda. Help me write add as a lambda. One second, let me just get this sorted. This thing keeps appearing on that. Yes, please go ahead. Func of
int,
comma, int, comma,
int, comma, int,
int, comma, int, comma, int, right?
O3
O3 equal to,
in bracket.
why are the parentheses required here now?
Parameters are more than one.
More than one.
Other than one. Don't say more than one. Say other than one.
Other
Because
than one.
what is the number other than one?
0 or more
0
than.
or more than one. All right. So remember it as other than one rather than saying more than one. Okay. Carry on. What are the parameters here now? A and
B.
Carry on. And then the
Equal to
lambda.
Return A plus B.
Don't give
Without
the
return
word
keyword.
return.
Without return keyword.
Just say
A plus
A
B.
plus B. So that is my add function being written here. If I had to call that function, similarly O3 of whatever 10, 20. Are we clear on this, everybody? Yes. Are we clear on this?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
All right. Help me call that is even. Is even. You all know the code, right? For is even. And don't make me write it down once more. You know the code for is even or not? This is the one. This was an anonymous method. So help me, if I have to do this with the lambda, help me write this with the lambda. Yes.
Predicate.
Predicate. Carry on.
Int.
Int. All right. Yes. Whatever. O4 is it? O4. Yeah. Is equal to, yes.
A.
Take A as a parameter and return.
So now, like we will have to write the rest of the code if to false.
So now, as far as possible, try and express it in an expression as far as possible. Sometimes it may not happen, but as far as possible, if you can do it as an expression, try and do that. So see what I'm doing.
So
E modulus 2 equal to 0. That's it. What is A modulus 2 equal to 0 going to return? What will this return?
Boolean.
It will return either true or false. Returns a Boolean value. Perfect. Correct or no? So if it returns true, if it is returning true, you are saying return true. If it returns false, you are saying return false. Yes or no? So as far as possible, try and keep it as compact as possible. Try avoiding longish code. Can we write long code in a lambda? Yes, we can. But the essence of the lambda, the reason why you're writing a lambda is to try and write it as an expression in the shorter code. So the lambda, every time you think of the lambda, think of a kiss. Right? K-I-S-S, kiss. Keep it short and sweet. right? So can we write long code? Yes, we can. But the beauty of the lambda, the essence of the lambda is to try and express it in an expression. If you're going to write long code, then the reason why you're writing a lambda is lost. Okay. So let's try this again. Okay, before that, let's try calling this. This would be what? 04 of whatever. This gives you either a true or a false. Okay, what if I had longish code? What if you wanted to write code like this? What would you do here in that case? Okay, so I don't recommend this, but if you had longish code, then you could have written it in this way. The same way that you wrote a function. So if you had longer code, do this. Okay. Let's try calling 05. This also works the same. What have I actually done here? What is this looking like? What does this look like? This looks like an anonymous method. Yes or no? This is the code that you wrote for anonymous method. This is the code that you wrote for a lambda. Right? Done. Questions, if any? All right. Give me a minute while I open a file. Okay. So I'm not taking anything more for today, right? We have stopped at a point where we have done a few examples with delegates. I'd like you to practice these examples, and based on these examples with delegates, I'm not done with delegates. I'm going to take many more things with delegates. So I would like you to be very comfortable with all this, because there are a lot of things that we've done with delegates today, because we're going to take this and now we're going to see actual applications of delegates. So I'm going to now take this code and play around with this code. So I'd like you to be comfortable with this aspect of code before I take it further. Okay, so I'm not taking anything more. We are ending the lecture in the next couple of minutes. This is the assignment that I would be sharing with you. So this is a collection-based assignment. Read the questions. If there is a question that you have for me, ask me the doubt whether you have a question about that. Take a minute to read through the questions, and if you have any ambiguity about what needs to be done, ask me that right here, right now. All right. Firstly, create a dictionary-based collection of employee class objects. Right. moment I'm saying that you want an employee class object only in there, what am I referring to? Will this be the non-generic type or the generic type?
Generic.
Generic type.
Generic.
So give me the syntax for declaring a dictionary-based collection of employee objects. Give me the way in which you'll declare this.
Hash table dictionary.
Sorry?
Hash table employee.
There is no hash table if in a generic type. What are the, if you remember, I think I might have the Excel file open. This is the generic type. Yeah. So what class could you use?
Dictionary.
Either dictionary or
Sorted list. Sorted list.
What is the difference between the dictionary and the sorted list? Come on, quicker answers, please.
Dictionary is not ordered.
It's not ordered. So whatever you would like to pick up, okay? Pick up either of the two. After, okay, so how do you declare it? If you're using a sorted list, for example, what will you use in that case? Help me.
Sorted list, angular bracket, employee.
Int employee.
There are two things.
Yes, correct.
E and value.
Int employee.
So what could be the key for an employee?
Employee number.
Employee number could be a key. And what would be the data type for this employee number?
Integer.
Int. So that could be your key. And value would be the entire employee object itself. So that's how you would declare this. Are we clear on this, everybody? All right.
Yes, sir.
Accept details for employees in a loop. So keep it in a loop wherein every time you're accepting a value, you ask him, do you want to continue? Yes or no. If he says yes, then continue. If he says no, then exit the loop. So stop accepting based on user input or yes or a no. Okay. After which display the employee with the highest salary. So figure out how you would do that. Maybe you might need to, don't use any existing functions for doing that. Okay. Use your logic for doing that. How will you find the employee with the highest salary? Then after that, accept the employee number to be searched. So accept a number, employee number, and display all the details for that particular employee. So whatever employee number that you are accepting, display all the details for that employee. Then display details for the nth employee, where n is a number accepted from the user. So I say, I want the 10th employee. So how do you display the details for the 10th employee? That is what it is. So this is the first part, this manipulating this, sorted list if you're using the sorted list. Next one is fairly simple. This is a separate question. Create an array of employee objects and convert it to a list of employees. After you display this, then display all the employees that are there in this list. So convert an array into a list of employees. That's the next statement, the next problem statement. Then the third one is the reverse. Create a list of employees, right? Obviously, you'll add elements to the list. Then convert it to an array and display all the array elements. So this is just changing from one to the other. So this is what would be shared with you, right? All right, so give me a couple of minutes to share this. But as I said, I'm stopping the lecture for today. I'm not continuing further. So you have got a half an hour extra time. Jao ji lo apni zindagi, right? And I will see you in the lab session. So lab session begins at 2, right? So that doesn't change. That begins at 2. Any final questions before I disconnect? No? All right. Okay, enjoy your
Thank you,
lunch
sir.
and see you at 2.
Thank you, sir.
Right, students. What time should we keep the lab then?
2
2 p.m. only?
Yeah, let them study, Nisha ma'am, let them study.
Yes, ma'am.
If they
Yes,
want,
sir.
they can do the lab on their own. So let's see how many of them want to use this extra time to effectively.
Right.
Let them do that. Whatever they want to. I said, "Jao, jilo apni zindagi, code karo, jo
Independent.
karna hai
Yeah.
karo." Half an hour today, CDAC doesn't control them. Okay, but
Right.
hopefully, in the corner of my heart, somewhere I'm hoping that they quickly try out the code.
Yes, sir. Yeah. Yeah. So students, I guess sir has conveyed you that you with your